Greetings and welcome to the series of lectures on equations and inequalities in one variable. 1.3 Sums and Differences. When working with one variable expressions, there's a lot of things that we'll want to do with them. But the first thing, let's go through and recap how to simplify expressions. We're going to use three properties that we're aware of: commutative, associative, and distributive. So let's run through those pretty quickly. Commutative property of addition just means if we have any two real numbers, let's just call them A and B, A plus B will equal B plus A. In the event, order doesn't matter. Likewise, the commutative property of multiplication means the same thing. We have two real numbers. A times B means exactly the same thing. We get the same result as B times A. And we have associative properties for addition as well as multiplication. That just means we're grouping them differently. So if we have three any real numbers and we group B and C together, then A plus the quantity B plus C will equal the group of A plus B plus C. So grouping doesn't matter. Associative property of multiplication, similar concept, where grouping doesn't matter. Again, if we multiply A and B first and then multiply C, that's going to get us the same result as the quantity of B times C multiplied first and then multiplied by A. And the last one here that we want to chit-chat about is distributive property. Distributive property means that over addition we can pass multiplication. So A times the quantity B plus C will be the same result as A times B plus A times C. And let's check out a few examples. So if we have 7x plus 4 plus 6x plus 3, we're actually using all of those three properties to simplify this expression. Now I know you probably already have jumped to the answer to where it's 13x plus 7 just by adding like terms, but here's all the things that you're really doing in between. So the first thing you probably did was commute, do the commutative property and put all the x's next to each other and all the constants next to each other. So you regrouped it, or pardon me, you reordered it. The second thing you probably did is you said, oh, to add like terms, I can only do x's with x's and constants with constants. Well, that's associative property. Then we did distributive property. You pulled out the 7 plus the 6 and pulled out the x out of each of those terms. And then finally, you simplified. 7 plus 6 is 13 times x. 4 plus 3 is 7. So even though you probably jumped to that answer pretty quickly in your head by using everything you know about like terms, you did use all three of the properties. Let's see another example. And again, we're going to use distributive, we're going to use associative, and I've probably even commuted in there as well. So 2 times the quantity 3y plus 4, then plus 5. So we're going to use distributive. Multiply 2 times 3y and 2 times 4 plus 5. Use associative because we're regrouping it. So instead of 3 times y first, we're going to do 2 times y, or 2 times 3 and then y, plus 2 times 4 plus 5. Now let's simplify this a little. I know what 2 times 3 is, that's 6. I know what 4 times 2 is, that's 8. So I have 6y plus 8 plus 5. And then finally, we're still using associative because I'm only doing the constants together. And I finally get 6y plus 13. Now you're probably still doing all of these steps, but you're doing a lot of them in your head. You're just following the rules and not writing it down. So here's another example. 4 plus 3 times the quantity 2y plus 5 plus 8y. I'm going to run through and distribute the 3 across the 2y and the 5. So I have 4 plus 3 times 2y plus 3 times 5 plus 8. That's our distributive property. And now I'm going to reassociate instead of 2 times y, I'm going to do 3 times 2 and make it 6y times 3 times 5 plus 3 times 5, which is 15. I'm going to reorder it so I have all my y's together. And in my head, I already kind of did the distributive property, so I pulled out the y. So I have 6 plus 8 is 14y, and 4 plus 15 is 19. Here's a similar problem you can try before I work through it. So I'm going to go ahead and work through it. And I'm first going to distribute the negative 3 to the 4x and the negative 2. So I have negative 3 times 4x is negative 12x. Negative 3 times negative 2 is positive 6. Now I'm going to combine like terms. I have a negative 12x and a positive 5x. That gives me a negative 7x. And an 8 and a 6 gives me a 14. Now if you remember your rules about distributing between binomials, that means I'm going to have to either use the FOIL method or I can use a vertical method. I'm going to use the FOIL method. First, outer, inner, last. Right? So I'm going to multiply first the first terms. X times x will be x times x. X times negative 4. Then I'm going to distribute. So first I did x times x. X times negative 4. Then I'm going to do the 5 times the x and the 5 times the negative 4. And then don't forget this, plus 3. I may have an error in my problem. Combine what you can, do the math of what you can. So x times x is x squared. X times negative 4 is negative 4x. 5 times x is 5x. 5 times negative 4 is negative 20. And that should be a plus 3. And then x squared, combine like terms, that's going to be a positive x. And negative 20 and plus 3 is plus 17. Oh, sorry, negative 17. Oh my goodness. I guess I just didn't like that positive 3. Now, addition and subtraction of polynomials, what we're going to do here is we're going to combine like terms. So we have to make sure that the variable as well as the variable's power is the same and we can add like terms. We're still using the associative, we're still using commutative, and then we'll finally use distributive to kind of get everything together. It's kind of happening in the background. Just like we were with the simplification of expressions, we're kind of doing this in the background. So let's see what I mean. Let's add 5x squared minus 4x plus 2 and 3x squared plus 9x minus 6. So the first thing I'm going to do is I'm going to bring those two together with an addition symbol in between. So 5x squared minus 4x plus 2 plus 3x squared plus 9x minus 6. Now I've reordered it and I can kind of group these things together and to add like terms. So I have 5x squared plus 3x squared. Well, you can see distributive property applies and I get 8x squared. Negative 4x plus 9x, again distributive property still applies, so it's really negative 4 plus 9 is 5x. And then 2 minus 6 is 2 minus 6, which is a negative 4. So ultimately, it's 8x squared plus 5x minus 4. Most of the time, it's not addition that gives us issues. It's subtraction. So let's subtract two algebraic expressions. 9x squared minus 3x plus 5 and 4x squared plus 2x minus 3. Now I've rewritten it with the subtraction symbol in between these two expressions. 9x squared minus 3x plus 5 minus the whole entire quantity, 4x squared plus 2x minus 3. Now here's what I'm going to do first. I'm going to go ahead and use my commutative property, but I want to make sure that when I'm bringing these two things together that I'm always subtracting them. Instead of adding them, I'm subtracting them. 9x squared minus 4x squared. Negative 3x minus 2x. 5 minus negative 3. And when we have a minus negative, I can change those into positives. So that's going to give me 9 minus 4 is 5, so 5x squared. Negative 3 and a negative 2 is a negative 5x. And a 5 plus a 3 is an 8. That's one way of looking at it. The other way of looking at it is, remember, there's an implied 1 here. Let's distribute this negative 1 to all of the terms in our second expression. So that will give me 9x squared minus 3x plus 5 minus 4x squared minus 2x, and a minus is a plus 3. Now when you add like terms, you're still going to get the 5x squared minus 5x plus 8. So depending on what you like, if you like to think of it as all subtraction or you want to distribute that subtraction across all of the terms, is up to you how you decide to simplify the problem. Now, why go through the hassle of simplifying algebraic expressions instead of, I don't know, leaving them as they are? Because sometimes it's easier to simplify expressions and then we're given a value for that variable, and then we can plug it in. Because if I'm given an equation that's a little bit more, I don't know, wordy-some, I guess I'm going to call it, something like this, 4 plus 3, certainly that's a lot more complicated than 14y plus 19. And if I was given the value of y, I can plug it in only once, or I'd only have to plug it in once down here, versus I got a couple places up here. I've got some distributing to do. Ugh, it's a big old mess. So if I can simplify it as much as possible and then work with that value, hey, a lot easier, I think. So all of these are expressions that we've worked with in terms of what algebraic expressions are. They're just variables, addition, subtraction, has some operation symbols, has some grouping, has some numbers and variables. That's all an algebraic expression is. So let's find a value. So let's use our algebraic expression and let's plug in a value here. In essence, when x equals 2, my original expression 3x plus 5 becomes 3 times 2 plus 5. 3 times 2 is 6. 6 plus 5 is 11. Although my variable value is 2, my expression value is 11. And this expression value is going to change depending on what the value of the variable is going to be. Let's take that same expression, 3x plus 5, and this time x equals 10. So when x equals 10, the expression 3x plus 5 will become 3 times 10 plus 5. Well, 3 times 10 is 30, and 30 plus 5 is 35. So a different value for our expression depending on what our variable is, the value of our variable is. So let's look at a few more of these. Let's take the original expression of 5x plus 2. Let's give x the value of 4. What will the value of the expression be? Pardon me. Well, 5 times 4 plus 2. Wherever an x is, we plug in a 4. 5 times 4 is 20. 20 plus 2 is 22. Now let's take another example. 3x plus minus 9. When x is 2, I'm going to plug in a 2 wherever the x is, and I'll get 3 times 2 minus 9. Well, 3 times 2 is 6. 6 minus 9 is negative 3. Let's try another one. 4t squared minus 9. Well, when t is 5, it becomes 4 times 5 squared minus 9. 5 squared is 25. 4 times 25 is 100, and 100 minus 9 is 91. And of course, depending on what the expression is, it's going to change the expression value, even though maybe our variable value doesn't change. For example, let's say a is 2, but if our expression is a plus 4 all squared, then that's going to be 2 plus 4, which is 6. 6 squared is 36. But if our expression is a plus 16, then that's going to be 2 plus 16, which is 18. So even though our variable didn't change value, depending on our expression, of course, the value of the expression might change. Let's plug in a 0. 0 plus 4 is 4. 4 squared is 16. Versus 0 plus 16 is 16. Yes, we got the same value, but really we did a lot different thing to a to get there. Let's try another one. Let's try a is 3. 3 plus 4 is 7. 7 squared is 49. Versus 3 plus 16 is 19. So again, the value of the expression depends on the value of the variable. That's kind of it, the value of the variable. Let's try a little bit more complicated problem. Negative 2/3 x minus 4. And I'm going to use the value first of 0. 0 is always nice to work with. So negative 2/3 times 0 minus 4 is 0 minus 4. So the answer here is negative 4. If x is 3, we plug in a 3, and we got to remember our multiplication of fractions. So 3 I can write as 3 over 1. So it's negative 2 over 3 times 3 over 1. Multiply straight across. Negative 2 times 3 is negative 6. 3 times 1 is 3. So that's negative 6/3 minus 4. But I can reduce this negative 6/3 to a 2. So that's negative 2 minus 4, which is negative 6. And then let's try a fraction, negative 9/2. Now when I plug negative 9/2 in here, I can do something really nicely here, which is I can reduce. 3 goes into 3 once, 3 goes into 9 3 times. 2 goes into 2 once, 2 goes into 2 once. So all of this is really negative 1 times negative 3. Negative 1 times negative 3 is 3 minus 4, and 3 minus 4 is negative 1. Now we've focused on expressions with one variable, but we can use two variables. If we're given both of the values of the variable, then we'll get a constant as our answer. So let's say x is 4 and y is 0. Then I can plug the x into wherever the x is, the y into wherever the y is, and for our equation, our expression 5x minus 4y, we'll get 5 times 4 minus 4 times 0. 5 times 4 is 20, 4 times 0 is 0, so 20 minus 0 is 20. Let's try another one. Let's say our variables are now x is negative 2 and y is 3. I can plug those into our equation, and I have 5 times negative 2 minus 4 times negative 3. That will give me 5 times negative 2 is negative 10. Negative 4 times negative 3 is positive 12. Negative 10 plus 12 is 2. Now sometimes we're only given the value of one variable. Therefore, if I'm only given the variable maybe of x, and I say x is 3, but I'm not given any information about y, I'm going to leave y as y. So 3 goes in wherever x is, 5 times 3. Y is going to stay the same, so minus 4 times y. So ultimately I'm going to get 15 minus 4y. Now, I know I ran through that quickly, but try some of these problems out on your own and see how far you get with the expressions and evaluating expressions and simplifying expressions. So until next time, be seeing you.